Welcome to Food Safety 5, twice monthly reports from the Food Safety Magazine editorial desk to keep you abreast of top news stories and current events impacting the food safety sector. This episode of Food Safety 5 is all about Listeria monocytogenes. We're covering two recent scientific studies that are advancing the food industry's understanding of and ability to address the notorious foodborne pathogen. First, a recent study is the first to show that Listeria monocytogenes is able to colonize pre-existing biofilms in a matter of hours and survive over time without significantly altering the community structure, potentially offering it protection against cleaning and disinfection in food processing environments. In a laboratory experiment, a strain of Listeria monocytogenes isolated from the production line of a real-world meat company was introduced to pre-existing multi-species biofilm on stainless steel slides. The pre-existing biofilm comprised bacteria strains that are frequently associated with Listeria-positive sampling sites. The researchers observed the behavior of Listeria monocytogenes within the biofilm, finding that it was able to colonize the multi-species biofilm within 2 hours. After 7 days, Listeria monocytogenes continued to survive in the biofilm, representing 2.4% of cells without any significant changes in its abundance and without altering the biofilm community or its matrix composition. The researchers believe that their findings could suggest that Listeria monocytogenes is a passive survivor and resident of biofilms in food processing environments rather than an active player. Another study by researchers at the Canadian Food Inspection Agency has demonstrated the capability of a streamlined workflow to detect low-level presence of Listeria monocytogenes in food samples within 8 hours. This is a vast improvement from current laboratory methods, which take 24 to 72 hours to identify food samples contaminated with a low level of the pathogen. The researchers designed a sample-to-answer detection workflow by integrating various methods such as culture enrichment, filtration-based sample processing, magnetic separation of target bacteria, and real-time polymerase chain reaction. They evaluated the workflow using ground beef samples artificially contaminated with Listeria monocytogenes in 25-gram analytical units, and were able to detect the pathogen within 8 hours in a unit containing as few as 2 Listeria monocytogenes cells. Once the streamlined procedure is evaluated thoroughly and implemented in food microbiology testing laboratories, it will significantly reduce the turnaround time for Listeria monocytogenes testing in food samples, said lead researcher Min Lin, PhD. For more information on any of the stories mentioned in this video, be sure to check out the Food Safety 5 magazine coverage linked in the description of the video. Check back twice monthly on Tuesdays for the latest Food Safety 5 episodes, available at food-safety.com or on our YouTube channel.